Today, we are going to focus on AKS 37, which discusses samples and populations. We are going to understand that statistics can be used to gain information about a population by examining a sample of the population. We are also going to learn that generalizations about a population from a sample are valid only if the sample is representative of that population. Finally, we will understand that random sampling tends to produce representative samples and support valid inferences. So our learning target for today's lesson is I can make conclusions about a population based on a simulation of random sampling. The first thing that I want you to do is copy down these definitions in your notebook. Before we can understand whether or not a sample is valid, we must first understand the difference between a population and a sample. A population is the entire group of items or individuals from which the sample under consideration are taken. In more basic terms, the population is the large group of people that you would like to find out something about. The sample is the smaller group chosen from the population for the purpose of collecting data. So the sample would be a small group, and we would like it to represent your population fairly. So let's look at some examples. A principal wants to determine which lunch students prefer. He surveys 50 students on the 7th grade hallway. The population would be everybody that the principal wants to know about. Well, I know that the principal wants to know which lunch students prefer, so the people he wants to find out about are all of the students in his school. The sample is the small amount of the population who he surveys. He wanted to know about all of the students, and he chose to survey 50 students on the 7th grade hallway. Those 50 students would be the people in his sample. Next, the manager of a department store wants to know how many sandals to order for the upcoming season. So he plans a survey to determine how many customers prefer sandals. He asks the first 100 customers in the store on Friday which type of shoe they would prefer to buy. In this problem, the manager wants to know about the customers at his store. So all of the customers would be his population. The sample is the people from which he chose. So he was looking at all customers, and he chose to survey the first 100 customers in the store on Friday. Those first 100 customers would be his sample. Next, a TV producer wants to know adult viewers' favorite genre of show to watch. He selects 300 adults randomly from a phone book to survey about their favorite TV show genres. In this situation, the population is everyone that the producer wants to know about, and we know that he wants to know about adult TV viewers. The sample is the small group that he chose to survey. In this case, he surveyed 300 adults randomly from the phone book. These would be his sample. When we take a sample, we want to make sure that we always survey a group of people that is representative of the entire population. The best types of samples to use are those that are unbiased and random. An unbiased sample is a sample that accurately represents the population. This means that it is fair and everybody had a chance to be selected. A simple random sample is a type of unbiased sample in which each item or person in the population is as likely to be chosen as any other. An example of this would be a teacher places the names of all students in a jar and shuffles the names around and then chooses a name at random. That is a simple random sample. Every student had a chance to be selected. A systematic random sample is another type of unbiased sample, and in this type, the items or people who are chosen for the sample are chosen based on a specific time or item interval. An example of this would be a principal wants to know about everyone in his school. So he stands at the entrance of the school and surveys every 20th person who enters. Everybody in the population, which means everybody at the school, would have had a chance to be selected for that survey. However, he chose the people based on a specific interval. So every 20th student who entered the door, that is a system that he uses to select his students. Now, sometimes we use samples that are not valid. These are samples that would be biased or not random. If you use these samples, your data is not going to accurately represent the population. So these are the best samples to avoid. We want to make sure that we never use a biased sample. A biased sample is an unfair sample or a sample that does not accurately represent a population. In this sample, one or more parts of the population are favored over others. A biased sample may be something as simple as asking all of the football team members if they think that more money should be donated to sports. Well, people on the football team play sports, and they likely want more money to be donated to sports. However, they do not necessarily represent everybody at a school. So that would be a biased sample. A convenient sample is a sample that consists of members of the population that are readily available. A convenient sample may be you want to know about everybody at your school, and so you ask the students sitting with you at lunch. Although these students do go to your school, they don't necessarily represent everyone at your school, and not everybody had a chance to be selected. So this would not be a good sample to use. Another bad sample to use would be called a voluntary response sample. In this sample, we take a survey of people who want to participate. An example of this is you give people a survey and ask them to mail it back to you. Or you pose a question to people and you ask them to call in and give their answer. Sometimes examples of this are giving surveys to people and asking them to complete them online. In most of these situations, the people who respond have very, very strong feelings one way or the other, but these people do not necessarily represent the whole population. So let's look at some examples and see if we can figure out what type of sample they've used and whether or not that sample is valid. A random sample of students at a middle school shows that 10 students prefer listening to rock, 15 students prefer listening to rap, and 25 students prefer no music while they exercise. It can be concluded that half the students prefer no music while they exercise. I notice in this problem that it says that a random sample of students at a middle school shows, which means I have taken a simple random sample. Because my sample is random, that means that every student at the middle school had a chance to be selected. So they all had an equal chance, which means this would be a valid conclusion. So because the conclusion they make, which was half the students prefer no music while they exercise, since that was based on a simple random sample, I can say that their conclusion is valid. Next, I see that every 10th person who walks into a department store is surveyed to determine his or her music preference. Out of 150 customers, 70 stated that they prefer rock music. The manager concludes that about half of all customers prefer rock music. For this survey, it seems as if the manager wanted to know about the customers at the department store and what type of music they preferred. The manager chose every 10th person who walked into the store. This means that the manager chose people based on a system. This is a systematic random sample because everybody who walked into the department store had a chance of being selected, but only every 10th person actually did get selected. Because this is a random sample, the conclusion that the manager made is valid. Next, a city council member is surveying people in the city to determine their favorite leisure time activity. He is in a music store and decides to survey the people there. He finds that 85% prefer listening to music, 6% prefer playing sports, and 11% prefer reading. I noticed that the city council member wants to know about people in the city, and he decides to survey the people in the music store because he is in the music store. Because he's surveying people who are in the same place as him, I would consider this a convenience sample because he's surveying people who are close to him, but they don't necessarily represent everybody in the city unless everyone in the city is at the music store. I also noticed that in the conclusions, he finds that 85% of the people prefer listening to music. Well, this is not necessarily true about everyone in the city, but it would definitely probably be true for people who are at a music store. So because of this, I could say that this was a convenience sample, or I could also argue that it's a biased sample because I'm unfairly representing one group of people. Both of these would be good samples to call this. Because these are biased samples, I know that the conclusion that the city council member made is invalid. Most of the music store customers probably like listening to music, and not all members of the population had a chance to be surveyed unless they happened to be in the music store at that time. So because of that, this is an invalid conclusion. A radio station asks its listeners to indicate their preference for one of two candidates in an upcoming election. 72% of the listeners who responded preferred candidate A, so the radio station announced that candidate A would win the election. I noticed that the radio station asked its listeners to indicate their preference, which means the radio station was waiting for people to tell them their answers. This means that people may have filled out a survey online or called into the radio station, but not everybody who was a listener had a chance to be selected for this, which means this is actually a voluntary response sample. This is probably consists of people's results for people who actually really have strong feelings about either candidate A or candidate B. So because this is a voluntary response sample, I know that a voluntary response sample is biased, so these conclusions are invalid because not all members of the population had a chance to be selected.